All right, so let's start this online topic test and look at question number 1. It says, choose the graph that best represents the situation. The temperature of the water decreases over the first few hours in the refrigerator. So which one is showing that the temperature of water when you first put it in there starts off probably kind of warm, and then it's decreasing and going down over the first few hours? So would it be something like this where it goes at a constant rate and then goes up? So as my time progresses, is my temperature increasing? No. So does B look right? Well, it starts off my temperature maybe at room temperature 70, 75 degrees or whatever, and then it's going down, 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 then all of a sudden it goes back up? No. What about C? The temperature's going down, down, down over our first few hours. And then probably what's going to happen, and you don't see this, is that it's going to flatten off. Why do you think it's going to flatten off and stop decreasing? Yeah, it's going to get to the temperature that this refrigerator set at. Is it set at 35 degrees, 34 degrees? Right? You want a refrigerator to be a little bit above freezing, right? 34, 35, 36 degrees typically. So that looks like C would be the correct answer. It's a pretty easy question, right? All right, let's go to the next problem. Number 2, it says the sales of the company have increased steadily over the years. So increasing, right? So it looks like it's starting off kind of slow and then accelerating a little bit more. Or is it the sale going down and then back up? Or sales dropping down, decreasing as the year goes through? Or is this one, the sales go down, 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 and then look like flatten off? Which one looks the most accurate as far as it increasing over the years? Steadily. That means pretty straight line as much as possible. Looks like it would be what? What do y'all think? Okay, I agree with you. All right, let's go to the next one. Problem number 3. It says the temperature changed as Shelley preheated the oven, baked the bread, and turned the oven off. So what happens whenever you preheat the oven? What happens? Temperature's going to go up, right? And then what happens, do you think? It's going to stay steady for whatever the temperature was, right, that you want it to be. And then what happens? And then you turn off the oven, what's it going to do? Drop back down. So which one shows it going up, staying steady, dropping back down? There you go. All right, let's go to the next one. All right, so the next problem says, select the answer which best describes the relationship given by the table. So in this table, I have got to find a function rule. So we're going to look for a pattern in the table. So I'm going to rewrite the table over here so we can see this. Here's my X, and here's my Y. And I've got a 0, 4, a 1, 3, a 2, 2, and a 3, 1. And I want to see if I see a pattern in the table. All right, so look at this. We're going to see if there's a pattern. Look at my X's. My X's are increasing by 1. Do you agree? So 0 plus 1 is 1. 1 plus 1 is 1. Or they have a common difference of 1. Right? If I subtract the latter minus the previous, I get 1. 1, 1. What about my Y's? What's happening with them? It's going down by 1. Down by 1. Down by 1. Is that a constant rate of change? What do you think? Or is there a constant slope? Yes. What is it? Well, constant rate of change is just the change in y over the change in x, which is the same thing as slope. And my change in y is negative 1 over a positive 1. Just like this is a negative 1 over a positive 1. Negative 1 over a positive 1. It's easy to see that a change in y being going down by 1 as my x's are increasing by 1 would reduce down to be a negative what? 1. So my rate of change is a negative 1. My slope, that's the same thing as slope, is negative 1. So if I have a common difference of negative 1, a first common difference, what does that tell me about my function rule to get y? What does that constant rate of change tell me? It's that negative 1 saying I'm doing to x. I'm multiplying it by negative 1. So it just means negative 1 times x. And that will give me that's my function rule for every point in that table, right or wrong. Well, let's check it, since you don't know. Let's take, to get y, I took negative 1 times x. Here's x is 0. What's negative 1 times 0? 0. Very good, like it's supposed to be a 4. So it didn't work out. But I do know, since there was a common difference of -1, that that is what I'm multiplying x by. So to get it to work out for that first number, what would you do to get the right y, which is 4? To get 4, I'd take -1 times x plus 4. And that would work for the first one, but it has to work for every one of them. So let's try the next one. Let's take -1 times x, which is 1 this time. What's -1 times 1? -1 plus 4. What's -1 plus 4? 3. It works out. Does it work out for this one? Plug in x is 2. X is 2. -1 times 2 is negative plus 4. What's -2 plus 4? 2. Very good. It works out for it, right? So y is 2. Let's try one more. 3. -1 times 3 is -3. Plus 4 is what? 1, like it's supposed to be. So we found the right function rule. It's -1 times x plus 4. So which one says it's -1 times x plus 4? Which one of those is the same equation? Looks like this one. Y is equal to -1x. There's not a 1 there. It doesn't have to have a 1 there. -1 times anything will give you that thing back. So another way of writing that is -1 times x is just -x. Right? Because -1 times anything is that thing itself, but it's just the opposite of it. Plus 4. So is it a function? Yes or no? 0, 1, 2, 3. If all those x's are different, then yes, definitely that's a function. So there's no doubt that that's C. Let's go to the next one. Select the answer which best describes the relationship given by this table. Let's speed this one up a little bit and see if we can find a relationship in this table. I've got a 2, a 0, a -1, and a -1. Right now, is that a function? It's not going to be a function because I have 2 repeating x's with 2 different y's. I got a -6, a 0, a -5, and 5. But even though this is not a function, can I find a function rule? Well, let's see. Let's see if there's a common difference right there. So -6, what would you do to that to get it to become a 0? You added 6. To get 0 to become a -5, what do you add right there? So I subtracted 5. Right, from a 5 to a +5, that would be adding what? 10. As this is increasing or decreasing, right, by 2. This one did what? Decreased by 1. And this one stayed the same, so it had a decrease of 0. So if you look at your change in y over the change in x, is 6 divided by -2 the same thing as a -5 divided by a -1? No. See, this is actually a -3 is not equal to a +5. So there's not a constant rate of change. Do you agree? So it's not linear. Okay, it's not going to be a line. It's going to be some sort of a curved line. It could be a V or it could be a U, it could be an S-shaped curve. How do I find out what the pattern is? Well, I could see if there's a common second difference. Okay? So if I try a second difference, I would have to take a difference of these and a difference of these, so I get -2, right, to a -1 is a increase or decrease of what? Increase of 1. From a -1 to a 0 is an increase of 1. So that's kind of helpful, right? I get the same value there. If I found the change in the second difference here from a +6 to a -5 is a, what is that? Is it an increase or decrease? It's a decrease of 6 to get to 0, and then another 5 would be a decrease of 11, right? And then 5 to 10 would be an increase, or -5 to a 10 would be an increase of what? 15. So there's not a common second difference, right? So it's not quadratic. So maybe it's something else, right? Could it be an absolute value? We looked at those, and we also looked at cubic ones, right? Maybe I'm cubing something, all right? So if I look for that next pattern, could I find a next pattern in that? Well, maybe I'm repetitively multiplying by something and being exponential. -6 times what is 0? Well, that doesn't help me, right? Because -6 times 0 would give me 0. So maybe I'm multiplying by 0 repetitively, which that would never going to happen. So 0, 0, you kind of ignore to see if that's a pattern there. So if I go from a -5 to get to a -1, there's just opposite numbers there because I have the same axes. So maybe possibly I'm multiplying by a negative or something each time. So maybe it's y is equal to a -1 or a -1 to the x power. right? So I could look for powers and rules. Okay, I could do all of that stuff, or I could simply use my answer choices. I know it's not linear, right? So it can't be A. And it's not a function to begin with, so I can eliminate A and B. Don't you think so? And it's not going to be linear because it's not going to be 5 times x. It's not linear, it's not 5 times x. So the only relationship that's true right here is what? D. It doesn't even want the function rule. Because maybe there's not a function rule, maybe it's just random points. Okay, so in that problem, it's just simply D. We got that? Do we understand? I guess we could have stopped as soon as I got here and say, hey, it's not a function. Okay, let's go to the next one. Each set of ordered pairs represents a function. Write a rule that represents the function. So this is a function, right? Look, 0, 1, 2, my x is 3, my x is 4. All my x's are different, so it's definitely going to be a function. Okay, so all I have to do is find a function rule that represents that. Now, y'all do know that on your test you get to use your calculator, right? So what I could do is I could try to create a table and find a pattern. And we could do that real quick. We could go, alright, if x is 0, y is 0. If x is 1, y is 3. If x is 2, y is 6. If I got a 3, I got a 9. If I got a 4, I got a 12. And then I could sit here and try to find a pattern. Or I could almost just randomly guess and check. Let's try to find the pattern, though, so I don't have to do that and just guess and check and use my calculator by plugging it in and looking at the tables. Let's see if we can find a pattern. This is going up by 3, by 3, by 3, by 3, as this is going up by what? 1. Do you see a constant rate of change? The change in y over the change in x. Change in y over change in x is what? 3. So I know my function rule is y is equal to 3 times x because I'm repetitively adding a 3 each time. It's a constant rate of change, which is going to be a linear function. So it's y is equal to 3x. Everybody agree? Well, let's check it. What if I plug in a 0? What's 3 times 0? 0. What a 1? 3 times 1 is 3. What about 2? 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Yes, I found the right function rule. So there's only one that says that, and that's B. Now, once again, like I said before, you could have gotten that just by randomly guessing and say, all right, I guess B. Then go to your calculator and graph it by going to New, or your home screen. Then go to New Document. Do I want to save my last one? No. I could add my graph, and I could have randomly guessed one, like B. And I could have plugged in y, or f of x in function notation, is equal to 3x. Watch. And then hit enter. Well, that visual picture of the line doesn't help me with a table of values that I recreated from the ordered pairs. So I can just call up the table by going to Control T. And look, there's a table of values that is related to this ordered pairs, right? Isn't these ordered pairs an x and a y, an x and a y, x and a y, x and a y? So let's go find those x and y's and see if it's the same thing as what we created with our table. 0, 0, 1, 3, 2, 6, 3, 9, 4, 12. Yay. We picked the right one. We know it's right now, so we checked it with our calculator, right? Not too bad so far? Now let's go to the next one then. Each set of ordered pairs represents a function. Write a rule that represents the function. Y'all want to just randomly guess and check? Would that be a good way of doing it? Not really, but you can. All right. I'd rather you not. I'd rather you actually try to create the pattern and see if there is a pattern. But if you just want to randomly guess and check, we could. Let's just try a couple. And if I don't get it right after the first two, we're going to calculate it, okay? So anybody want to guess one? So go to my home screen. Go to New Document. Don't save my last, and let's guess. What'd you say? So add a graph and guess A. Somebody said A. So let's take x minus 8. And then hit enter. And then look at your table. Control T. Is that the right table for those ordered pairs? Do I have a 0, negative 8? See, there's a 0, negative 8 here. And there's also, in my order pair, 0, negative 8. That looks good. 1, negative 7. 2, negative 6. 3, negative 5. 4, negative 4. We didn't even have to do any calculations, did we? Okay? We let our calculator do that. Is that a good way of doing it? Not really, but it's a good way of checking your work. Okay? So we could have done it with a table of values and found a pattern like we did in the other two. Now, in this one, we're not going to guess and check. Here's the next problem. We're going to actually try to calculate it from a pattern. Okay? So I'm going to give you an x and a y. And we're going to plug in some ordered pairs. 0, -7. We're going to make a table from those ordered pairs. I'm sorry. And then we're going to see if we find a pattern. I got a 2 and a 3 and an 8. X is 3, y is 8. And then if x is 4, y is 13. So let's find a function rule. How do I find y? We'll see if there's a pattern in the table. To get from 0 to -7 to a -2, what do? We're adding something. What'd you add? Isn't that 5? From a -2 to a 3, isn't that adding 5? From a 3 to an 8, isn't that adding 5? From an 8 to a 13, isn't that adding 5? As my x's are increasing by what? 1. So is this a function? Look at this. All my x's are different. Yes, this is a function. And do you know what type of a function it's going to be? Linear or nonlinear? It is linear. Very good. Why is it going to be linear? There's a constant change in y over change in x. The change in y over the change in x is constantly 5 over 1, which is what? 5. And if that's 5, it's telling me that the slope of the line is 5, but it also tells me that 5 times x is what, or I'm multiplying 5 times the x to give me my y's. Right? Doesn't that work for every ordered pair now? What's 0 times 5, right? 5 times 0. If I plug in that x, which is 0, into my function, isn't 5 times 0 equal to, not -7, it's equal to what? 5 times 0 is 0. So what do I do to get it to equal to a -7? What would you subtract from 0 to give you a -7? Subtract 7. So subtract 7, and now I get a -7 when I plug in a 0. So if I use this function rule, y is equal to 5x minus 7, does it work for a 1? Does it work for a 2? Does it work for a 3? Does it work for a 4? Instead of having to plug it in the whole time, guess what I can do? Go to New Document. Use that function rule in your calculator to see if it works for all these, because I'm having to calculate 1, 2, 3, 4 extra ones. And instead of me making an error in the calculation, why don't I just plug in my function rule? Y, or f of x, equals 5x minus what? 7. And then hit enter. And then go to Control T to look at the table. What do you notice? So I don't see a 0, but I do now. Isn't my table the same thing, right, as the table that I originally have? So is my function rule correct? What should it be? -5x plus 7? Or should it be what? Positive 5x minus 7. So which one says that? None of them. So guess what? Is D. Right? They don't have the right function rule. You need to answer those. Do it now, so it's due before you leave. Yeah. All right, so let's look at the next problem. Each set of ordered pairs represents a function. Write a rule that represents this function. So once again, I'm doing the same thing. Okay? So here, I got a table. Let's make this table and find a pattern. 0, 1. 1, -1. 2, -3. 3, -5, and 4, -7. See if I can find a pattern. Well, look, my x's are increasing by 1, by 1, by 1, by 1. As my y's are doing what? To get from a 1 to a -1, that's a decrease of how many? Very good, 2. From a 1 to a -3 is a decrease of 2. From -3 to a -5 is a decrease by 2. So what is my rate of change? Or what is my slope? Or what am I multiplying x by to get y? What am I multiplying x by to get y? The change in y over the change in x is negative 2 over 1, negative 2 over 1. So my slope is negative 2, and I'm multiplying my x by negative 2 to get y every time. And that works for all of those, right? So plug in a 0 and see. Is y equal to a negative 2 times 0, which is 0? Nope, it's supposed to be a 1, right? So how do I get that to become a 1? Maybe if I just add 1 to the end of it, add 1 to the end of it. That would work for the first one. Does it work for the rest of them? Well, let's see. Let's just plug them in the calculator and see. Take negative 2x plus 1, plug it into your calculator, and construct a table and see if it's the same one. So go to New Document. Same thing we did in the last problem. Add the graph. Plug in that function rule that we think it is. We think it's negative 2x plus 1. So plug in a negative 2x plus 1. All right, and then call up the table by hitting Control what? T, like Todd. And then I've got to make sure I have a 0 in there, so move it over here to the left and then move up. So I got a 0, 1, 1, negative 1, 2, negative. Did I find the right one? So do you know how to use your technology to help you on those problems too? Yes, we good? Any questions? So which one says negative 2x plus 1? Negative 2x plus 1. None of them. D again. All right, let's go to the next problem. It says, write a function rule that represents this sentence. 1 more than 2/3 of A is equal to, it doesn't say that, but when it says is, it just means is equal to B. So if I write that function rule, it would be 1 more than, so I'm adding 1 to something, and I'm adding 1 more than 2/3 of A. What does of typically mean? Typically means you're multiplying it by something, but if you're taking 2/3 of a number, there it always means multiplication. So it's 2/3 of A, so it just means 2/3 times A is equal to B. Now since I'm adding, I can add in any order. The commutative property of multiplication or of addition says I can add in any order. So another way of writing this is 2/3 A plus 1 is equal to B. Okay? So it could be either one of these two equations. Do you see anything that says that? There we go. Got another one right. All right, so let's go to the next problem. It says 11 less than the product of a number y and negative 2 is z. So if it's 11 less than something, right, is that going to be 11 minus, or is it going to be 11 taken away from something? So is it some number minus 11? What do y'all think? Is it 11 minus some number blank, or is it some number minus 11? Yeah, you're taking 11 away from something. So what am I taking 11 away from? It's 11 less than the product. What does the product mean? What are you doing with two things? It's the answer to a multiplication problem. So it's 11 less than the answer to a multiplication problem of what? Some number y and negative 2. So it means I'm going to take negative 2 and multiply it by some number y. And that's the product of negative 2 and y, but I don't know what y is, so that's why I'm writing it that way. And then I'm going to subtract 11 from that. So my equation would be what if I clean it up? Negative 2y, and it's 11 less than the product of negative 2 and y. And that is equal to what? Z. Do y'all see that anywhere? C. Yes, ma'am. Yeah. All right, let's go to the next problem. 6 times the sum of a number t and 5 is equal to s. So 6 times means I'm multiplying it by something. What am I multiplying it by? The sum. So I'm going to take some number, and that should be in parentheses. 6 times the sum of some number t and 5. So I'm going to take 6 times, right, the sum of some number t and 5, and that would be equal to s. So before I multiply that 6, what I got to do is I got to find t, the sum of some number, and t. That's what it's saying to do. So do I see that anywhere? 6 in parentheses, t plus 5 is equal to s? Yes. Any questions about that? Are we good? All right, let's go to the next one then. All right, if f of x is equal to negative 5x plus 11, so if I write that down, and f of n is equal to 21, what is the value of n? So it's saying if you plug it, and really what it should say is the output f of x is equal to 21. What it's really saying is what would x be? So what did you plug in, right, for x to get an output of 21? So to clean this up, another way of writing this is if f of x is equal to 21, what would your input value be to give you that if you multiply negative 5 times that input value and add 11 to it to get 21? So what would that input value be? We'll solve that equation. So we go back to chapter 1 and solving equations. What's step 1 of solving any equation? Distribute first, right? There's nothing to distribute. Step 2, combine like terms on the left and the right. Step 3, variables on one side, constants on the other. That's where I'm at. I've got a variable and a constant. I got to get this constant over here somehow so I can actually pick it up and move it, or I can use opposite operations to get rid of it. So subtract 11, and 11 minus 11 is 0, so that's not there anymore. And I'm just left with what on the right side? Negative 5x. And then on the left side it would be 10. So now I solve this by my last step, which is to isolate the variable. So to get rid of a negative 5, what do? Divide by negative 5. Negative 5 divided by negative 5 is 1. 1 times x is x. So what's 10 divided by negative 5? It would be negative 2. So the question said, if you plugged in a negative 2 into your function, what would you get back? 21. So my answer would be a negative 2. Do you understand what it's asking you? Are you done? Okay, let's go to the next problem then. Thank you. Identify the domain and range of this relation and determine whether it's a function. First of all, let's look at it. There's the x. There's an x of negative 3, then it's a 0, then it's a 1, then it's a 2. Are all the x's different? Yes, so guess what? That is a function. So yes, this is a function. All right, so let's look at those. The relation is a function. The relation is not a function. It can't be B, right? So we can eliminate some answer choices. The relation is a function. The relation is not a function. So it's either what? A or C. So let's look at the domain. I'm just going to abbreviate that D. What are the members of the domain? That's the x's. Just look at the x's. What's the first one? Negative 3. Then the next one is? Then? Then? There's my domain. Look, is that a negative 3, 0, 2, and 6? That doesn't look right, right? Is it a negative 3, 0, 1, and 2? By process of elimination, it should be C, but let's just make sure we don't make a mistake. Let's look at the range. All right, so what's the range? That's the output values. It would be an output of a 6. An output of a, when I input a 0, I get an output, or a y value of a 2. What's my next y value? 0, and then my last one would be a? Very good. So is that what this one says? Negative 3, got it. 0, got it. 2, got it. 6. Why is it not in the same order as mine? What did I tell you earlier? They're going to put it in what? They're going to put it in order from least to greatest on the test. Same way on the EOC if it's one like that. All right, let's go to the next one. Identify the domain and range of this relation. Tell whether it's a function. First of all, is it going to be a function? Negative 1, 0, 1, 2? Yes. What's the domain? Negative 1, 0, 1, and 2. So far, does A look good? A looks good. Let's check out the range. All right, my range would be the y's. So I've got a negative 4, check. Right, there's a 0, got it. Y is 4, got it. Y is 8, got it. Oh, there it is. We got it right. It's A, right? Okay, couldn't be anything other than A or C. What's wrong with C? I mixed it up, didn't I? Okay. Let's go to the next one. Find the range of the function for the given domain. Now, I'm going to tell you by far the easiest way of doing this. Look how many input values I'm going to have to do. Right? So I'm given x's. If I'm given x's, what can I do to find the y's real easily? Plug it in your calculator. So what I'm going to do is go to my home screen, go to New Document. Don't save my last one. I'm going to add a graph of what? Right, I'm adding a graph of this f of x is equal to negative 2x plus 1 so I can see the table. So plug it in. This will be the last one we're going to do. And I'll give you the rest of the time to work on it yourself. Then go to Control T. Right, why did I go to Control T? Because I'm given the domain. I'm given these x's. Find the right y's. Look. X is negative 2, y is 5. So which one says a positive 5? Find a positive 5. This one has a positive 5. Right, what about 0? 1. Look, there's a positive 1. Looks good with A so far. What about 2? 2's a negative 3. Got it. All right, let's go over here. Let's see another value. All right, so what if x is a 4? I'm at a negative 7. There it is. See it? Last one. 6, I'm at a negative 11. So guess what it is? A. Okay, you have the rest of this to do on your own, okay? Can y'all get it? I've given you a lot of answers, so y'all should make a good grade. Have it done by Monday because that's when your test is.